I am from Argentina. I am currently there. So the pandemic won't let me live here, but I started developing websites when this browser was being distributed. Netscape, the first function of Netscape. I don't know if anyone in the audience come from that time. And then I dedicated myself to do mobile development. I have been giving courses, training, and consulting for a lot of large companies and small companies in Latin America, United States, Europe. And as Diego said, there is a lot of content from me in many publishers of online courses and a lot of books. And I like to write. I like to write a lot about the topics that I like, which are web performance, the topic of today, and also progressive web apps. Recently, I launched a website which is called Firt.dev, which is a compendium of all my articles, talks, and free content that I have generated. But today, I have two objectives. Today, the first one is to make you feel bad. Yeah, I want you to feel bad. This is the first goal today. And the second is for you to learn some new tricks that you may not know. So let's see if I can achieve the following goals in the next 25 minutes. So we shall begin. I know that I am going to tell you that I know that you know several things. First, your users are sad, your users are frustrated, and you know that there is money involved here. So to bring this to education, we will put some Mexican pesos here, but you are losing money. Who is losing money? The web developer or the owner of the website when we develop a website? So our customer is losing money because web is money. This has been demonstrated. I know that you know. So I'm not going to explain this a lot, but this is mainly because this is the responsibility of the front end. We are in the JSConf, so this is our responsibility. Maybe not our whole responsibility, but we do have responsibility of the performance of a website. It doesn't have to do with the cloud, but it's always or mostly a front-end problem. And I know that you know that there are user-centric metrics. Lately, we have been using about those created by Google, which are called Core Vitals by Google, which are a set of metrics that are oriented to user perception. So how do we measure web performance? If we're going to do it by the perception that I get my phone and I say, well, that was fast, but I don't know how fast was that. That's my perception. Another problem that we have is that page load, that was an old metric that we used when I started in the 90s. It does no longer make sense today. So the most common today are calculated over the 75th percentile. Explaining it quickly, of all your visitors, 75% have to have certain minimum in mobile and in desktop. So metrics today most used are largest contentful paint, which measures the initial load, how fast it is loading the largest content in the first page. Then we have the first input delay that measures interactivity and how interactive our website is, or how problematic it is when we want to interact, scroll, tap, and it doesn't react. Then we have this cumulative layout shift that measures the visual stability. I think you have seen that sometimes we have some trouble when we go into a website. We read and then a banner appears or something that moves the information that we were reading, and we are upset by that. So when we are upset, that makes the user not to like our web, and that is CLS. There are more metrics: speed index, time to first byte, first contentful paint, where that's the first pixel or the first background, and time to interactive, which is the moment in which the website starts working. Those are user-based metrics, but most of you would say, hey, that's not my problem. My website is quick, because we just are testing it, with our phone, or we just looked at it, or it is better than average mobile and maybe with a better than average connection. But that is not how we measure that. Today, our goals that we have to achieve, which are set by the community and sponsored by Google, if I have to be honest, and followed by the community, is that the large contentful paint is in 2.5 seconds. So for 75% visitors, 2.5 seconds is the time where the most important content should appear. 4 seconds is acceptable, but it is not ideal. The first input delay is 100 milliseconds, 300 milliseconds maximum, and the CLS is not measured by seconds. It's something given by the tool, and that means that the website moves little, 0.1, and the maximum is 0.25. And I know that because you are in this conference, that we need to optimize resource transfer. We need to reduce the amount of files that we download from the server so that we can give that first paint. So we have to compress the HTML, the JSON, JavaScript, everything that is text needs to be compressed from the server side. So I know that you need to work with TLS and HTTP too, and the site must be safe. This is basic today for every website. I know that you know how to use CSS just as an appetizer, which means that our main meal is the content or the service that we offer, and the CSS is the appetizer. It should be the smallest as possible. We're not going to eat 4 tacos as an appetizer. It has to come before everything, and it has to be very small, because without CSS, the browser will not render anything. And JavaScript should be dessert. It's going in the end. It is very sweet, and it has a lot of energy consumption power. It is very sweet, and it needs to be delayed because it uses the execution thread, the same that the web browser uses to render and to paint the web. And I know that you know how to optimize images. You're not going to publish a logo that is 4 megabytes heavy, and then the browser has to make smaller. We know that that's wrong. And then you have created it through a compression tool. And I know that you can use service workers, something that has been mentioned before in JSConf yesterday and today. And you already know that. So you're doing already everything. This is basic. So we are already doing this, of course. I trust you to do this. So what is the problem? Why are we talking about this in JSConf if we are all doing what we have to do? The problem is that today, the median or the average of time to interactive is the time in which a website is available to be scrolled, to be tapped. The average is 9.3 seconds in the world for websites. 9.3 seconds. This comes from the HTTP Archive Foundation, which analyzes this continuously. This is updated. So you will say, okay, that's not a lot. Well, we'll see how much is 9.3 seconds. .3 seconds. That hurts. So the time is really a lot of time. Imagine that you're waiting for a subway or maybe for the bus, depending on where you are, and 9.3 seconds may decide, maybe not in the time in the middle of a pandemic, taking public transport, but maybe you miss the train because you didn't see it. And 9.3 seconds is a lot of time. So Google says that if a page takes more than 3 seconds to load, 53% of the users abandon it. And we are talking about the average of 9. So there is a problem. There is still a problem. We have always underestimated mobile in many ways. Nowadays, the mobile is iOS and Android. We know this. We're not going to argue about that. But does that mean that means that it is Safari and Chrome strictly? Well, that's not that very simple. There are many browsers today with enough market share to make us test our website in those browsers. So those are Samsung browser, UC browser, Opera Mini, and the last is Chrome, but not any Chrome, is iOS Chrome or Android Chrome. And the goal for all of you who are users of iPhone and iPad, Chrome in an iPhone is not Chrome. It looks like Chrome, but it is not Chrome. It is because Chrome forbids the publication of other engines. And there is another browser that is not considered. Most developers or designers do not consider this browser. Have you ever tested in this browser? It is this one, Facebook. Facebook has a browser incorporated. It is called Facebook Mobile Browser. And when you click or tap a Facebook post and it has an external link, by default, it is opened in this browser. And this is not the same engine in the browser that you have installed in your phone. It is different in performance, in API capabilities, and in versions of scripts and things that we can do and we cannot. Have you tested your website or your app from React, Angular, or Vue in Facebook mobile browser? Even a friend in Twitter last week, I asked him if he had some data about what percentage of people or visits come from Facebook mobile browser. He has a report that he makes called Mobile Overview Report, where he gets statistics, and the latest statistics is that 7.6% of global smartphone traffic comes from the Facebook app. That is quite a lot. Those are millions of users and visits, and we have never worried about testing there. Another problem that we have in mobile is that we use the mobile network. And many of us think, well, we have 4G, so performance is not really a problem. So let's take a look at that. This is the latest information from the GSMA, which is the global organizations from all mobile operators. 65% of the people in the world has smartphones, so 35% don't. But those who have 4G, at least in 2019, is 52%. That means 52% in the world. In Latin America, that depends on the country, but Latin America is a little bit below, around 47, 48%. That means that other percentage that one would say uses 3G. But if we look at the next graphic on the right, 3G is 25%. So we have, this turquoise here that is 4G. Then 3G is 25%, and the gray area is 2G. A lot of people are still browsing in 2G, even if in the United States. So 4G is not necessarily the solution yet. And when we talk about 2, 3, or 4G, our brain just rapidly identifies bandwidth. Clearly, 4G has a better bandwidth than 2G, and 2G, 3G, and 5G has better bandwidth, but 5G still does not appear in the percentages because the usage is still very small. But bandwidth is not the most important thing for improving web performance. It is more important to be able to see Netflix in 4K, or today that Disney Plus came out for Latin America. That's important if we want to look at it in 4K. So we need bandwidth for that. But when we browse the internet, we are downloading many files and very, very small files. And the bandwidth is not that important. It's the latency, the round trip time, which is the time that information takes from going back and forth the server. So the latency is coming down. But DSL is not 5G. DSL is a local connection that we have in our home, a cable connected to the router in our home, or maybe an ADSL. 4G latency is still 10 times bigger. So even the percentage that has 4G, which is not everyone, that percentage has a greater latency. So every packet that comes and goes takes longer. So we still have a lot of performance problems. I should tell you something. There is Chrome Light Pages. I don't know if you've heard about this. Chrome Light Pages exist from Chrome 73 in Android. If the user enables Data Saver, if that is enabled, because that appears on the first time that you open Chrome on your Android, you will be shown by Chrome. Instead of showing a web app, it's going to show a light page if your user is in 2G, or if you are in 3G or 4G, but Chrome estimates that the first contentful paint of your website is beyond 5 seconds. So if the user is not going to see anything in the first 5 seconds, Chrome is going to decide to send the light page. So beyond having an icon indicating that it is a light page, it renders the web app in the cloud, not in the client, which changes a little bit. And those are smart optimizations. Not all images are being loaded by default. So is that what we want in our website? No, we want to have control of what's going on. Another topic, which is why performance is important, is progressive web apps. Those web apps that can be installed. Those can be in the store, in the Google Play Store. For example, 1-800-Flowers is a store, and COVID-19 official application from Panama called Panama COVID is in this store. But you need to have a minimum performance of 80 in this testing app, which means that this is very important. We need to hack the web performance. We need to make even more. So in the following minutes, I hope that I have made you feel bad, which was my goal. But now it is the second goal, which is show you what can we do to improve this. So in the next 10 minutes, I'm going to give you new tricks. First, we're going to hack the first load. We're going to avoid more than one round trip to the server. So when the packet comes from the server, that is enough to paint enough in the website for the user to be comfortable. So this is why we're going to use TCP slow start. I'm not going to get very dense in network because I don't have time for that. But most servers today are Linux-based servers. We have a limit of 14.6 kilobytes for the first packets. So if the first server reply is more than that, you're going to take more time. And well, what is a kilobyte? I am going to give you a question and you can use the chat for the answer. How many bytes are in a kilobyte? I know that for many, that's a very easy question. Like, how dare you ask this in a JSConf? Well, let's check the answers in the chat. Many of you are going to say, well, 1024 bytes, 1 kilobyte is 1024 bytes. Well, I regret to inform you that no, maybe this is the only thing that you're going to remember, but 1 kilobyte is 1,000 bytes. And if you do not believe me, ask Siri, ask Google, or ask Wikipedia. You don't have to believe me. What we really know about 1024 unit is the kibibyte, the one that has an I in the middle, the mebibyte, tebibyte, etc. So yeah, kibibyte are 1024 bytes. So to avoid more than one round trip, we need to send a packet of 14.6 kibibytes. So how much is that? How can we achieve that our website gets into that size. So we need to separate the above the fold, which is what you see in the first scroll, which was below the fold, which is, of course, when you scroll later. So we need to deliver the above the fold in 14.6 kibibytes, every CSS, every JSS that comes in. And if you still have space, add an embedded logo in base 64 or low-res images. But 14.6 is very little, but you need to remember that it is compressed. It is an HTML and it's zipped. So that probably means 70 and 80 kibibytes or kilobytes if you want. But that doesn't sound too bad for that little Windows piece. That is the first trick. The second trick is to avoid redirect from HTTP to HTTPS. If I log in, if I enter to JS-ConfMX, I do not type HTTP://. Of course not. The first thing the browser does is going to HTTP, and then it redirects to HTTPS, and that is a waste of time. There is a way called HSTS that allows us to define a header that tells the client, the browser, hey, this website that I'm going to go in is always going to be HTTPS. So from now on, you will always have to go to HTTPS, and that redirect can save us half a second. We can also opt in htsspreload.org. So what it does is that it whitelists our website. So the users that have never entered our website are always going to go directly to HTTPS. Next, we need to hack data transfer. It is important to begin using HTTP3, which is mounted on a protocol called QUIC. It is still in beta, and it works over UDP. Those who know networks, do not worry, because QUIC adds the necessary so that packets do not get lost. It reduces latency and message congestion, and it can improve performance in more than 10% without touching anything. This is available in Chrome. Those are a lot of users, especially in Latin America. And it is available also as an experiment, and you have to enable it in the settings, but soon it will be available for all users. So it works the same as HTTP2, so nothing has to be changed. Only the transport protocol has to change. Next is using Broadly. This is configured in the server. Broadly can save even 25% of transfer compared with gzip. This is a compression algorithm that allows this HTML, this 14.6 kibibytes, can have more content inside. So you need to verify that that is placed in the server. If you have a service such as Cloudflare, you need to enable that. Then is hacking resource load. For example, modern cache. What is that? I know that you all know how to make a very neat cache. I remember that web programmers were enemies of cache. We used it as an excuse. If the customer says, I don't see the change, we use this as an excuse. Well, it must be the cache. Well, the cache must be used smartly. It is a static. Every static resource must have a 1 year expiration. It's very long expiration to maximize the probability to have this resource already in the client. Today, it's very common to have a hash in the file names that is used in React and Angular and other libraries and frameworks, that the build process generates a hash. So the main bundle.js is not called main bundle, it's called main bundle and the hash, and that hash changes. So there is a new header so that the browsers do not make a conditional request. That means that the browser has to have JavaScript or HTML looks for it, and the browser says, maybe there's a new version, let's ask the server. And all of that takes a while because you have to go to the network. And since we know that this resource is not going to change, we can use this cache control, immutable, which is compatible with all the browsers, the browser knows that this file is never going to change in the server, so it is never going to make a conditional request. So that's interesting. Then you need to heat up the engines. We need to download resources from other servers, maybe images, JavaScript files, and we can help the browser to begin that connection with those servers as soon as possible. For example, the DNS query can take 150 milliseconds, and TCP TLS connections can take 200 milliseconds. And you can just announce those DNS queries with DNS prefetch with a link tag, and we let the browser know that later we are going to need resources from this domain, so please start making this DNS query. We can even tell it to connect to that service, so start sending those private and public keys and all these handshakes from secure connection. Just start doing that, because we will going to need that soon. And you can announce that in the header, in the HTML response, instead of inside the content of the HTML. And finally, we can do preloading, which is helping the browser to handle the priority of loading the resources with a link tag and a preload, telling the browser that we're going to require that CSS file. And we can do that in the header. We are going to require, for example, a font, .wav. So before the browser knows that there is a CSS style and that style is going to require that font, we're telling the browser to start downloading that, because without typography, you do not have text. And without text, we do not have good metrics, like the first contentful paint. So we're going to tell the browser to begin this. Even we could add priority hints. And for this, with the importance attribute, to every links and to every image tags, what importance do they have? So we can help the browser to download the images that we prefer before others. So this is interesting. And talking about images, well, we need to hack images. We realize that an image is worth more than 1,000 words, but that is if it downloads. If we do not see the image, it was not important. So it is very important. Many websites add this and improve performance immediately. This is lazy loading. Adding this means that not every image is going to download. They are going to begin downloading when they are about to appear on screen. So, for example, this works as well for iframes or banners. If you are watching them, then they are downloaded. But if you are not watching them, then they are not downloaded. When you start scrolling them, then they are downloaded. So that makes that other resources which are more important are downloaded. And finally, it is time to replace JPG and PNG. And for that, we have other image formats. For example, WebP, which can reduce 34%, or ABIF, which is new, 40%, and only runs in Chrome and desktop. It will going to come in Android soon, and it's going to arrive in Firefox soon. So we can begin using ABIF, smaller images, and if you do not like those formats, at least keep using PNG, but change the compressor. There is a new compressor called Subfly, which reduces size in 20%, and this is even compatible with Internet Explorer, with everything. And JPEGs, we can put it through a compressor called Getzli. Those are German names, so they are not easy to pronounce. So this is important that we know. And finally, we need to hack what you know. You use React, Angular, Vue.js, and other frameworks or client libraries. But think about what is more important, whether our love for the library or performance. And even if you do not like the answer, the more important thing is performance. We are not doing performance for performance itself. we are not doing it because we're fans of it, but because it is proven that if we have better performance, we will have better conversion and we will have more money for somebody, more users, more visits, more shopping. This is proven. So when we use these libraries, we need to start changing and thinking if we need to do something on the server side, like Next.js or Nuxt.js, or move to static generator such as Eleventy. So, for example, we have Eleventy is JavaScript, my computer runs it, and it generates purely static files. And there is a lot of new tricks to hack the web performance. Performance should be the number one priority, always, because without performance, there is no conversion, and conversion is what brings the money in for us to make development. So we need to push for more, and the effort is worth it. So, do you feel bad already? I hope you do feel bad. So, that was all today. Thank you very much. If you want the book, Hacking Web Performance, you can get it for free from my website. And it has some of the topics that we saw in this conference.